Hello, this is SM Khomne from College of Engineering, Pandharpur. Today in this lecture, we are going to discuss and have a demonstration of 3D modeling component and its drafting with the help of CATIA V5 software. So, let us start. So, by double clicking on icon, you will get this screen, and this is a by default screen of a product, and that is assembly. So, later on we will discuss about this assembly in next lecture, but let us discuss about the part design. So, this by default screen should be closed with the help of this small cross. If you click here on this cross or in this on this close, software will get closed. So, you should close this small cross button. So, before starting any mechanical component, you should have this kind of screen on your computer, and then you can understand there is no any workbench started, and this is a just blank screen. So, to start, there is a one button at left side top, that is a start. If you click on that particular button, then you will get list, and out of this list you have to choose the mechanical design. And in mechanical design there are various options available. So, first one is part design, assembly design, sketcher, and many more, including drafting and all these. So, now today we are going to discuss how to prepare part and how to prepare its drafting sheet, which is necessary for shop floor for production purpose. So, click on this part design option, you will get one dialog box at left side, and here it is expected that you should put component name here. It is also allowed to put component number also. So, now here we will keep name as it is, and we will click OK. So, this will be the my part number 1. People can give another name, like we are going to prepare elbow in this particular tutorial. So, people can give the name elbow also. So, if you click on that particular dialog box, you will get this kind of screen on your computer. So, at left side you will see the tree. This center you will observe all planes are available, and this side this is a compass, which plays very important role in assembly. So, now let us discuss this particular tree. So, whatever operations will be performed by user, it will get inside this particular tree, and people can click on that particular operation, and people can edit it also. So, now we will see the first plane is a xy plane, and if you click on that particular xy plane, that this middle plane gets highlighted, it becomes of orange color. If you click here on yz plane, another plane will get highlighted, and if you click on another zx plane, this vertical plane is getting highlighted. So, imagination of these planes is a very important part in CATIA, because all plays important role in a 3D modeling. So, at the beginning you can select any plane for the sketch. Without selecting the plane you cannot prepare the sketch, and sketch is necessary to prepare the 3D modeling. So, now we will discuss some of the toolbars which are very frequently used for single 3D model. So, many toolbars are not necessary at the beginning. So, I will suggest to close such a toolbars which are not necessary. So, with the help of this small line which you are observing on toolbar, with the help of that line and clicking left click of your mouse, you can move the particular toolbar. Also, you can make these toolbars vertical by clicking your left click of your mouse, and by clicking the shift button of your keyboard, this toolbar will become a vertical, and vice versa also it is. Now, suppose I do not need some toolbars. So, just by clicking this red cross, you can close unwanted toolbars, and I will suggest you should not keep many toolbars on your screen, so that you can use maximum space which is available on screen. So, first toolbar is a view, next one is a standard, sometime apply material, then sketch based feature, then workbench, sketcher, dress up feature, then transformation feature, then this not required toolbars I will close, sometime planes many time in a complicated models. So, this capture analysis, so this capture also I will close. So, on screen you will observe some of the toolbars are very important for 3D model, and if you find that some toolbars are required, but it is not there on screen. So, there is a bottom bar, on that particular bottom bar you can right click, you will get a screen or dialog box, and rather you can say this is a list of toolbars. You can observe some toolbar name has gray blue tick mark in front of it. Its meaning is that this particular toolbar is available on screen. You can see standard toolbar is available, workbench is available, view is available, apply material, dress up feature. So, all these are available on your screen, and if you want to bring any more, so just by clicking on that particular toolbar you can bring this toolbar on your screen. So, I will suggest that your toolbar must be at specific place. So, this toolbar should be moved with the help of left click of your mouse by holding this toolbar's top side, and in this way you can adjust all the toolbars on your screen at a specific place. So, this is the suggested places of toolbars on your screen, so that you will utilize maximum space from the screen. Now, you can observe this is a whole blank screen you are having, and here you can start your work. So, whatever toolbars I have suggested, these toolbars are necessary for our elbow component. So, as I had told that for preparation of any 3D model, sketch must be there, and for preparation of sketch there should be a selection of plane. So, by selecting plane you have to click on this sketch command. Its meaning is that I need sketch on this xy plane. Here it is highlighted. So, now once I click on that sketch command, I will go to this particular screen of a sketcher. Now, you can observe here all 2D commands are there, and here people can prepare all kind of sketches, and after preparing a sketches people can go to 3D model and students can prepare the 3D object. So, here also I will suggest some workbenches. So, like very essential toolbar for preparation of sketch is a profile toolbar. Then next toolbar is workbench, which was there in a part design also. Then another toolbar is constraint. Then next one is operation. Then this standard and view toolbar is common for all the workbenches. Workbench is nothing but where we are working. So, generally in CATIA people use the terminology of workbench. Then next, keep these toolbars at specific place as per the requirement. So, this is the method which I follow every time, so that student will easily identify where is my toolbar, and they will not waste the time for searching the toolbars and commands. Now, I have told that these toolbars are required for preparation of sketch, and in a last workbench we have seen these are the 3D toolbars required for the 3D model. Now, we will start preparation of profile, and we will move to this 3D, and there we will prepare the 3D component. So, now there is a requirement of sketches, that is sketch must be close profile. So, let us consider here you will observe a rectangle. If I click on that particular command and if I click twice on my screen at two corner, I will get a rectangle. So, by default this sketch is a closer profile. Now, if I prepare sketch like this, and if I double click to end this sketch, continuous sketch, you can observe that this sketch is a open profile, as first point and last point is not at one place. Suppose if I will prepare another rectangle inside the one rectangle. So, now still I can say this as the closed profile. So, now I will delete this triangle as it is a open profile. Now, if I prepare one rectangle and which will cross the previous drawn rectangle. So, now you can see this is also not a closed profile, it is an open profile. So, reason I will tell that you can see here there is a one 90-degree angle. So, you can see from this point sketch is becoming an open profile, means indirectly you can remember that if sketch is a or two lines are crossing each other, it is not a closed profile, it is a open profile. So, I hope you people understood the concept of closed profile and open profile. This is a mandatory requirement of CATIA. Let us say another example, circle. So, if I prepare one circle and if I prepare another circle inside one circle, now it is a closed profile, but if I prepare one more circle which is a crossing to another circle, definitely due to this crossing my profile is getting open. So, remember in CATIA two lines should not cross each other, so that it will become a open profile. I hope with the help of another example also you understood the concept of closed profile and open profile. By selecting the all sketch with the help of your left click of your mouse, you can select the sketches and you can delete the drawn sketches. There are options of trimming also, one by one we will discuss that also. Now, another concept of sketch is that sketch must be constrained. Now, if you see, if I hold this line, so I can move this particular sketch on my screen in a horizontal axis and vertical axis. Here sketch must be constrained. Its meaning is that it should have 0 degree of freedom. It should not move from one place to another place. So, now we can constrain this sketch with the help of this constraint command. And here one similar meaning to this constraint is that giving the dimension to sketch. If I click on this sketch command and if I select the any edge, I will get the dimension of my sketch. Here suppose there is a one circle. So, if you want to give dimension to circle also, then also you can use same command and just you can select the arc, you will get the diameter. And suppose you want to edit this dimension from 40 to any other dimension, just double click on that particular dimension and you can give your own new dimension with the help of keyboard. Here instead of diameter you also can choose the radius and you have to say OK. Here in linear dimension also same case is there. If you double click on that particular dimension, suppose you want to prepare 90 dimension instead of 100, you can type 90 and you can enter. So, you can see the change in your sketch. Then third dimension is there, that is a angular dimension. Suppose you want to mention angle between these two lines. So, you can mention that particular angle with the help of same command. So, in short, you can understand that for giving all kinds of dimensions you can use the same command. You can select and you can delete it. Now, I was telling about the concept of constraint, that moving the sketch in particular dimension, restricting the movement of particular sketch in a particular direction. Now, we will select another edge, this is a one dimension. Now, you can observe in earlier case dimension of rectangle was changing, but now it is not changing, because I have constrained with the help of this 90 dimension and here with the help of 40 dimension, but still it is moving on screen. Reason is that still I have not fixed this particular sketch. Now, same constraint command I will use and I will give my dimension from this horizontal axis to this particular distance. So, now you can observe that this particular lines becoming of green color and remaining 2 are as it is. Now, you can observe that if I try to move my sketch in horizontal direction, it is moving, but if I try to move in a vertical direction, it is not able to move. Reason is that I have constrained my sketch with the help of this dimension from horizontal axis. Now, you may have understood now that if I give dimension from this vertical axis to this line, now both lines will become a green and my sketch is not able to move on my screen. If you try to move anywhere, it will not move. Now, my sketch is constrained now. So, you can close this window as we are going to move to our another component. So, before that, let me summarize two things in CATIA. That first thing is that my sketch must be close profile and it must be constrained. Now, one more thing I want to explain, that in CATIA, if you double click on any command, that commands will move or command will continue for further many operations without clicking on command. So, to deselect it, you can click like this. So, now I will delete these circles and now I will move to our one command, that is circle, and we will start preparing the flange of elbow. Let us consider these are two circles. Just I am preparing the close profile of flanged elbow. So now I will give dimension to my all these circles, and I will try to make my sketch constraint. So I will make it a round figure like radius 40, radius 30, radius already it is at 10 and 20. Now I will prepare bitangent line, which is here. So before going for bitangent line, let me decide the distance between these two points. So I will reduce this distance from 90 to 70. So my sketch will look like actual flange. Now we will come to this bitangent line. So you can draw bitangent line with the help of these two arcs, and with the help of quick trim you can trim some part so that your profile will become close profile. So some part may be mirrored, and with the help of control you can select many elements, and you can select mirror and click on this horizontal axis and quick trim unwanted part. So now you can see this my profile is a close profile which is not intersecting any line, and it is also having a green color. Now this is my flange. Now I have to exit the workbench with the help of this command, and I have to click on one command, that is a pad command. So pad is nothing but giving the thickness to your sketch. If I click on this pad command, I will get one dialog box of pad definition, and I can choose some specific dimension like 10 or so. Now my flange is ready. You can choose now this face, and you can prepare profile and path for L shape. So for that, now you have option of choosing the face. In earlier case we were not having, so that's why I am choosing now this face. Click on sketch, you will direct it to this sketcher workbench. There you can prepare cross section of pipe in this way from center, and you can give dimension to your this cross section of pipe. Maybe preferably you can match this internal diameter of this hole, that is 30, and this may be 35. Now this is my profile cross section of pipe. Now I have to prepare the pipe. So to prepare its path, I should select perpendicular plane so that I can prepare L shape here. I will click on sketch command, and now from this point I will draw straight line, and by clicking left button of mouse I can prepare the curvature in this direction or in this direction. Now you can give dimension to this pipe and you can decide the dimension of your L shape. So, I will say this is also 90, and from this axis this distance will be not required to give, as it is a already mentioned, but still we can mention the dimension that 130 distance. Now I will exit it. I have two profile, that is a center curve and cross section of pipe. To use this particular sketches, I should go for rip command. If I click on rip command, it is asking me that first is a profile, obviously it should be a closed one, and center curve, it is a open profile. So I should select appropriate sketch, that is first one is a profile, which is a closed one, and center curve as a second profile. And if I say OK, then my pipe is ready. You can see this is a hollow pipe. Now same flange I have to copy. So as I have told, whatever operations you have done, it is there in your tree. So I have performed pad with the help of sketch 1 and rib with the help of sketch 2 and sketch 3. Now suppose somebody want to edit this sketch by just double clicking on that particular screen command, you can go to your sketcher workbench and you can use fit and all to bring your sketch in on your screen. But we are not required to do anything, just I want to copy the sketch by right clicking I can copy this sketch and I can paste this particular sketch, but sometime it will not match. So better way to use, change, go to sketch and say change sketch support, so preferably sometime this problem happens due to dimensioning issue. If dimension is not equal, then such a issue may happen. or you can copy and you can paste directly, as there is one problem in a mismatching. So, now that problem we can avoid. So, as I have told that this dimension should be equal. So, we have prepared that this has a 90 distance and this has a 80 distance. If you change it and if you make it 80, your problem will get solved and your sketch will match exactly. So, check that in such a cases, if you want to copy the sketch, then these two length must be equal, as we have made one mistake in our case, that is why it was not happening. Now, ready close profile you can use for the pad. Select the sketch in a reverse direction, so that it will go there, and if we will say OK, now my this will match exactly, this flange will match exactly. You can use this chamfer and fillet to your sharpened edges. So, you can use this and angle and some length. You can increase length from this side. If you say OK, so your chamfer is ready. So, similar way you can follow for another side also. Now, next is that fillet. You can use this command as a edge fillet, and you can prepare fillet here. Similar way here, and you can say OK. So, this is my ready 3D model. You can rotate by pressing your scroll button of your mouse and right click of your mouse in this way. If you want to pan, by just moving pressing your button of scroll mouse, you can pan it, and if you want to zoom in and zoom out by scroll button and right click, you can zoom in and zoom out in this way. So, now this is my ready model. I can save this model on your computer by creating some folders also. Now, we will minimize this. This is my ready component, and I have to prepare now drafting sheet of the same. Now, we will click on start button to select the drafting sheet. So, you can select mechanical design and now new workbench, that is a drafting. So, drafting is very important, because 3D model cannot be given, rather only given to workshop person and they will not understand. So, we should give all views, internal things and its dimensions, which was not available on our 3D model. So, due to this, drafting is a very important thing in a CATIA. So, now if I click on start mechanical design and drafting, you will get this dialog box on your screen. So, here you can make some modifications also, as already it is a first angle method which we prepare. Here also you can change it, but we will keep it as it is. So, here if I click, I will get the all views. If I click here, I will get the front, bottom, right views, and if I click here, I will get the all front, top and left view. But generally select the empty sheet and modify this sheet by choosing the portrait or landscape. Generally, if you select the A4 size, then select the portrait page only of ISO standard. If you click OK twice, then you will get one page in front of you, that is A4 size page. Here you can give the all details of your view. So, one thing is very important, if you are going for drafting, your model must be open on your screen, and then only you can perform the drafting. Here almost I am going to explain the shortcuts to you, but still there is some important toolbars for you people, that is views, dimensioning, annotation, etc., and remaining toolbars are not that much important for drafting, but as per requirement we should use it. Now, so I should use this first command of front view, and I should bring my front view of our model. Just click on front view and go to window, select that particular part and give the direction for the 3D. So, let us consider this will be my direction for front view. I am looking from this side. If I click here, I will get this kind of front view on my screen. This is a compass. With the help of this compass, you can rotate your object and you can change your orientation also. But this is a good orientation. If I click once, now my 3D model become a wireframe kind of, and it is here. You can see this is a front view of 1:1 scale, and on this A4 size page it is a too big. Now you can select this front view and right click on that and go to properties of this particular front view, and here as 1:1 scale is there, you can change it from 1:5. If you want to increase the small component, so you can use this scale oppositely like 5:1. So, 5 time enlargement is possible, but we are going to reduce the scale. Once I use the 1:5 and if I say apply or OK, so it is a too small, so it is proportionally I will put as a 1:4. So, this will be the good proportion, so I can accommodate all the views on my screen. Now, I want to take the bottom view of or its projection I want to take. So, by just clicking on this projection view command, you will get all views, like in first angle method you will get bottom view, top view here. So, you can see I got top view. Now, if I want to take another projection this side, I will get one view, this side also I will get one view, but these many views are not required at all. So, you can take all the projection of your front view. Then next one is you can take cut section of your views, or it is also called as offset section view. You can select this offset section view command and you can draw cutting line from top side to bottom side, and if you want to end the cut line, double click there and move your mouse where you want to keep your cut section view. In this way you can prepare section view of your object. Then next one is that I want to bring the isometric view of my component. So here with the help of window, you can go to window and decide the dimension. You can click here, you will get your isometric view, and which is having two big scale. So here we can go to right click and its properties, and we can click this 1:3 as a scale, and I will say OK, and it's a good one. Here I will change the scale of my front view, that is a 1:3, it is too small. I will say apply. So all views I will go and I will change, or multiple selection is also possible, that top view and section view properties will be 1:3. Now I want to tell one thing. Some views are having borderline of red color, but some lines are not having borderline of red color, it is of blue color. Its meaning is that this view is a activated view and you can perform the cut section operation on this activated view only. But if you want to perform the operation on any other view, then you need to double click on that particular icon, and then only you can perform the cut section operation on that particular component. Now my all views are ready, but its dimensions are not available. So you can use one command of generated dimensions and click on generated constraints. If you click it, some dimensions will come automatically, and you can rearrange these dimensions with the help of your mouse, which dimensions you have used at the time of constraining. Almost same dimensions came here. Rearrange these dimensions, and suppose some dimensions are not available, then also you can use this dimensioning toolbar, which is here. With the help of this chamfer, you can click the chamfer dimension and automatically 2:2, or you can change the length into angle also, and you can click here, you will get that particular dimension. Same case for the fillet also. You can select the fillet and just move the mouse, you will get the dimensions. So in this way there are variety of things which you can include here. Now one more thing is not looking good on this particular screen, that is this border lines. So purpose of this borderline is that if you want to move the any view on your screen, you can use these border lines. And one more thing is that if you want to activate any view on your screen, then this border line plays important role, but during printing these border lines are not looking good. So, by selecting all the views and by right clicking properties and by clicking on display view frame, you can delete all the border lines in this way. Next thing of after preparing your all views, nameplate is a important part which we will see here, and will stop for this session. So, now I will go to insert, drawing, before that I should go to edit, sheet background, and later on I should go to insert, drawing, and frame and title block. This is a procedure to bring the nameplate inside the sheet. So, now you can choose any one sample. So, I suggest always sample 1 is a very good one. So, if I click on OK, so I will get all the details of my nameplate. So, these things are editable. You can go to this name and you can use, or you can type, or you can delete also. By just double clicking on this particular text, you can change it. So, or if you want to add any text, so you can click here and you can type our college name, and you can say OK. In some cases, if that text is going outside, you can move in this way. Also, you have many options to edit the text also. So, you can change the font also inside the text, and size of font also inside the text in this way. You can choose any font, maybe bold or italic. So, like Word, there are many options. So, later on you can convert this particular drawing into PDF copy, so that anybody can take the print of it and people can carry anywhere in pen drive. Even software is not there, still it is possible. Say Control P and give the document name. On desktop we have created one folder, so you can give the name of your component elbow. So, now if you go to this folder which is there on desktop, so you will observe that PDF is created and it will be portable anywhere. So, here people can add the bill of materials also, material used also. So, that note can be added with the help of this text. Some people can give the roughness symbols also from here, welding symbols also from here, and welds, as well as people can add the tables for the bill of material or anything extra you want to add, it is possible here. So, this file you can save and later on you can edit also. So, at the beginning I have told to use the portrait page, so that this nameplate will fix very nicely and student can edit it. People can use like weight and all this also, it can deleted, and student can write their roll numbers here, because sometime in a table people use this. So, for weight sometime we may not be interested. Students can write here checked name of his or her teacher, given date and check date also, and automatically name will be written by student here. Here instead of decimal system, people can write their or they can keep as it is, as we are using this system. So, drawing number, instead of drawing number people can write the name of compounds also, or they can give some unique numbering which people used to give in a industry, like suppose TEA students are using this. So, T dash 04 number or TB division dash 04 number. So, this will be the unique code for that particular drawing, or people in industry use this is kind of things. So, this drawing is our property, it cannot be reproduced or communicated without our written communication or agreement. It is a automatic note is coming on this. So, this is prepared on license copies of CATIA V5. Thank you for watching.